and welcome to freephotoshop.com and part 12 in this huge series all about the levels command. At the moment we're halfway into discussing the sheer brilliance of non-destructive editing. In the previous video we looked at the adjustment layers option. In this video we're going to spend a bit of time looking at the advantages of editing inside the 16-bit mode, which as it turns out isn't actually a non-destructive way of working. You're still going to be losing a small amount of data as you make your edits, but what you do get from this particular technique is much more scope to alter and edit brightness levels and then be able to bring them back again. Okay, so let's start off by maximizing this document first and foremost. It's called 8 bits and channels, and then I'm just going to drag the layers palette out of the screen capture area so I can turn these layers on and off as I'm talking about them. So the first question here has to be, what actually is a bit? Well, a bit stands for binary digit, and if you know your computers then you'll already know that everything inside the digital world is written as a huge series of ones and zeros, and that's what digital information basically is. So one bit of information can either be represented as a 1 or as a 0. So the pixel is either switched on or switched off. Therefore, if we want to save out a black and white image, for example, we only need a 1-bit file format, because each pixel only needs 2 variations. It's either a black pixel or a white pixel. So the black pixels in the image could be represented by a 0, for example, and the white pixels could be represented by a 1. Okay, so that's all very well and good, but what if we want more colours than that? Well, you just need to increase the amount of bits afforded to each pixel. So if we have, for example, 2 bits of information relating to 1 pixel, we then have 2 variations times 2 variations, giving an availability of 4 different combinations with those 2 bits. So now we could save up to 4 brightness levels inside a 2-bit image. And the maths just continue from there. So a 3-bit image can accommodate 8 variations of the 1s and 0s, giving us 8 different brightness levels. A 4-bit image gives us 16 brightness levels, a 5-bit image 32 brightness levels, and then so on and so forth until we reach an 8-bit image, which is what's required for a true grayscale image, because an 8-bit string can accommodate up to 256 different variations, equaling 256 different brightness levels, which can run from black to white and also include 254 different levels of grey. Okay, another slant on things, we can also look at an 8-bit string of digits as 2, because there are 2 variations permitted in each bit, remember. So that's 2 variations to the power of 8, equaling 256 possible variations. Okay, so that's exactly what a true grayscale image is. Now if we want a full colour image, we need to start adding channels. So we already know that one channel of information is going to give us 256 brightness levels. If we add a second channel of 8-bit data, that's going to give us over 65,000 different variations. And finally, if we add a third channel to complete the specs needed for a full colour image, we build the total amount of variations up to 16.7 million, equaling 16.7 million possible colours, which is the total amount of colours available to us in an 8-bit per channel RGB image. Okay, I'm going to close this image up and then maximise the next one, entitled 16 bits and channels. Now you can see that if we increase the bit depth of the channel to 16 bits, then we're saying that we have 2 variations to the power of 15 available to us, and that's 15 because in these 16-bit images you'll find that at least 1 bit is used up for things like metadata. But now instead of having just 256 different brightness levels available to us, we have a massive 32,769 brightness levels. And just to give you an example of one 15-bit string of data, this is how the thing looks. So what we're saying is that inside these 16 digits there are a total of 32,769 possible combinations to lay the 1s and 0s out differently. Okay, so we still want access to a color image, so we still need more channels to add to the mix. So in our first channel we have over 32,000 brightness levels available. If we add a second 16-bit channel, we total up to over 1 billion colors that can be produced inside the same RGB color space. And then if we add our third channel into that mix, we get over 35 trillion colors available to us. And think of it as this. The 8-bit mode had, 16.7 million colors, which is way more than you could ever view on your screen at any one time. For example, the capture area of this video tutorial here at freephotoshop.com is 1024 by 768 pixels. That's only about 800,000 pixels in all, and we have 16.7 million to choose from. And now with 16-bit mode, I'm telling you that we have access to over 35 trillion colors, and we're not even using the 16.7 million from the 8-bit per channel mode in the first place. Well, part of you is right to say that this is just crazy. There's not a monitor in the world that can display 1 trillion colors, so why would you need to have them available to you here in Photoshop? After all, they're just going to take up more space on your hard drive. Your system's going to need more time to process them. Why on earth would you do it? Well, that brings me to my last point here under the heading of 16-bit advantages. The reason you're going to love 16-bit editing is because it gives you more editing flexibility. And that, my good friends, is what it's all about. Now, I want to give you a demonstration of just how powerful 16-bit editing is and the 16-bit mode is. I'm going to close this document and then open up the final minimized image I have down here, which just happens to be a photograph called eveningsunlight.psd, a photograph taken on Yarmouth Beach, as it turns out. And I'm not talking about the one in the UK, by the way. This is a private beach around the Cape Cod area in the United States, and at the moment this image is inside the 8-bit per channel mode. So in total it's a 24-bit image, and we can see that by the number 8 appearing up here in the title bar. You can see that the file name, the extension, the view size, and then the color mode, followed by the bit depth, which is 8. And the asterisk, by the way, is just informing us that there is a color profile associated with this document. Now if I want to double check that, I can come up here to the image menu, select mode, and right at the bottom here we have the 8 bits per channel option selected. Now I'm going to come out of that menu and bring up levels by hitting Ctrl or Command L on the keyboard. Now I'm going to take the output values down to 120 and 135 respectively. So now we're mapping all the blacks inside the image to 120, all the whites inside the image to 135, and we're cramming everything else in between those two brightness levels. So we're really reducing the contrast here. I'm going to click OK to accept those changes. Now I'll re-enter levels once again and look first of all at what we've done to the histogram and to the brightness levels inside the image. Now I'm going to apply the exact same settings as we did before, as if we haven't served enough punishment on the histogram here. So I'll map an input value of 0 to 120 and then set the other input value from 255 to 135, and then I'll press OK to accept those changes. And we're left with what looks like a complete grey image, although we know that we still have a few different levels of brightness available here. So we've still got some dark greys and we've still got some light greys, but because they're so similar, our eyes aren't able to distinguish between them. Okay, now I'm going to attempt to bring that detail back, so I'll re-enter the levels dialog box here, and look at how small our histogram is. I mean, this image is completely destroyed, but alas, we'll see what we can do with it. I'm going to drag the black and white sliders in so they meet this little baby histogram in the center here, and then I'll click OK to accept the changes, and we can see that we're starting to bring back some of those details. Now I'll re-enter levels once again and do exactly the same thing, and you can already see that perhaps our efforts are in vain because these single lines constitute our histogram, which is not a good thing, to be honest. I mean, if you ever see a histogram like this, then it's the need to start worrying, really. Okay, I'll click OK once we've drawn the shadows and highlights in to meet the histogram, and I'm going to see if Levels has helped me out here, and the results, as you're seeing on screen, are not that impressive at all. In fact, I'd go as far to say that this image is now a write-off. So that's the 8-bit example out of the way. Now I'll come up here to the File menu and select the Revert option to revert the image back to the state that's saved to the hard drive. Now I'm going to come up here to the Image menu once again, select Mode, and then come down here and switch not to the 32 bits per channel mode, because if you think 16 bits per channel is good, then 32 bits will probably blow your head off your shoulders. Anyhow, I'll switch this image to the 16 bits per channel mode, and now you can see what I was saying about the title bar here. The 8 has indeed changed to a 16, so we now know that we're definitely in the fully fledged 16 bits per channel mode, but you're not going to see any changes on screen just yet. The pixels that you saw inside the 8 bits per channel mode are not going to be affected one bit at the moment. In fact, if I bring up the info palette over here, and then I hover the cursor above the image, we're still going to see the brightness values on an 8-bit per channel basis. So they're still going to be between 0 and 255. What we need to do here to see the new brightness values that are relevant to the bit depth we're in is click on this little eyedropper icon next to the RGB values here, and then come down and select the 16-bit option. Now as I hover the cursor above the image, we're getting our true 16-bit brightness values on a scale of 0 to 32,768. Okay, now I'm going to hit Ctrl or Command L to enter levels once again, and I'll set our output values to match those that we set inside the 8-bit mode, so 120 and 135. Then I'll click OK. Then I'll bring up levels once again, and this time the histogram hasn't suffered quite as much as before, or quite as much as it did inside the 8 bits per channel mode, I should say. But it's definitely not a histogram you should be proud of, unless you're going for a low contrast effect, of course. Now I'll enter the exact same values once more, so 120 and then 135, and then I'll click OK. Now we've got the familiar grey ultra low contrast image, but now for the beauty of 16-bit editing, my good friends. Instead of just having a handful of brightness values left like we did inside the 8 bits per channel mode, because we started off with over 30,000 in each channel, we've still got literally hundreds left inside the photograph. Now they're all hanging about the neutral grey area, and once again they're so similar our eyes can't distinguish between the darker greys and the lighter ones, but trust me, if you will, they are there. And to prove it, I'm going to press Ctrl or Command L to reopen levels, and I'm going to drag the shadows and highlights in so we're effectively stretching out the histogram. Then I'm going to click OK, and we bring back a bit of detail. Now I'm going to re-enter levels once again, and see this time that all the brightness levels that were squished inside the histogram are starting to be pulled apart. I'm going to do the same thing again, just dragging these black and white sliders up to the tonal range, and then I'll click OK to accept the changes, and check that out. You really would be forgiven for thinking that this is every bit as good as the original image we opened up here. I mean, this is truly amazing. Now because we're in the 16 bits per channel mode, if I come up here to the File menu and select the Save As command, then come down here to the Format type, you'll see that we're now pretty limited as to which file formats we can save this as. The real popular JPEG format doesn't support 16-bit, but you can still use the PNG and TIFF formats, as well as Photoshop's PSD format. Now I'm going to cancel out of here. Now what you can do, and the way most people seem to work, is open up your images, switch the mode to 16-bit, carry out the edits, then if you have to save them as a JPEG, you can switch back the bit depth to 8 bits per channel before you save the document out. And if you're saving as a TIFF file, which is a far better way to work, much better than the compressed JPEG format, you can switch back to the 8 bits per channel mode and then save the image from there as well. And you really don't need to save, even though you can with a TIFF, you really don't need to save the 16-bit version of the image, because it wasn't taken as a 16-bit image in the first place. The great thing about 16-bit per channel mode is that you can work on an image even if someone else has applied what they believe to be the best levels adjustments possible and then saved it back to a JPEG. If you disagree, if you think you can do a better job inside levels, then you can still open it up and have control over the image and the colours and the brightness levels by switching it out to the 16-bit mode. It really is just a great way to work. I mean, you can see how badly I destroyed this particular image I've got on screen here, and we've managed to bring back the details to this amazing extent. Another advantage of editing in 16-bit mode, and you can try this out for yourself, is when you've completed your edits, you're going to be left with a smooth, compacted and perfectly unspoilt histogram. It's not going to be ripped apart like it is sometimes in the 8-bit per channel mode. You've got so many more brightness values available to you that you can almost get away with murder. In fact, you can get away with murder, in a figuratively speaking Photoshop way, of course. Well, I hope you understand just how much the 16-bit per channel mode can help you out when using Photoshop, and indeed when applying levels adjustments to your images. In the next video we're going to look at the auto and option buttons inside the levels dialog box, but for now I hope you're enjoying this series, looking at the levels command here at freephotoshop.com. I'll see you in the next video.